So this is lesson number 29 in Algebra 2, Uniform Motion Problems. And in the past uniform motion problems we had the distances being equal. So we may have said so-and-so started at this time and somebody else started at this other time and they traveled the same distance, and then we were able to look at RT and make those equal to each other, because RT distance equals RT, so then we could say that the RTs were equal to each other, and it gave us a chance to solve these. Alright, this is a different type of distance problem, and what we're doing with this one is we're taking the distance of one plus the distance of the other, and that is going to be our total distance. So that's what we're going to look at with this one. So it makes it a little bit different, but not really any harder. So what are the options here? We could have a starting point here, and you go this distance. You rest, spend the night, get up the next morning, and you continue on. And you've got two distances that you're adding together, giving you a total distance of, let's say, 500 miles. Another option is that you've got two people. One starts at school and goes to Dairy Queen. The other one stops at Hearts at home and goes to Dairy Queen. So you have this person's distance plus this person's distance, and that also equals 500, because you're taking the sum of both of those distances. Even though you're not going one and then adding, you're going here to here, and this person's going from here to here and meeting, but the distance is D1 plus D2. The other option is that you both start here. One of you goes this way, home after Dairy Queen, and this one goes back to the school after Dairy Queen. So you start at the same place, you just end up going separate or opposite distances or opposite directions, but you still end up going 500. Okay, so those are the three different options that we're going to do, and we're still going to use the distance equals RT setup, so that if we know that the distance of 1, it's going to be RT, plus the distance of 2 is going to be equal to our 500 that we came up with. So we're going to be adding our rate times times instead of just saying that they're equal. So those are the three options that we have as far as looking at distance problems. And one of the things that we're going to do as we're doing these next three examples is making sure that we have it set up correctly. So it's always good to make that real simple diagram there. So let's go ahead and look at example 29.1. Napoleon walked part of the 60 miles to the site of battle and rode the rest of the way. So he walked for part of it, so the distance walked, and then he rode. So let's put a dot there. Then he hopped on his pony and rode the rest of the way. So that's the distance that he rode. And it says that the total distance that he went was 60 miles. So the distance he walked plus the distance he rode was equal to 60 miles. Okay? So what else do they give us? He walked at 3 miles an hour and rode at 9 miles an hour, and the total time of the trip was 8 miles an hour. So let's see what we've got here. The rate that he walked was 3. The rate that he rode, or the speed that he rode, was 9. The time that he walked plus the time that he rode was 8 hours. Alright, so if we look at this and we know that D equals RT, we can say that dW equals RWTW, right? Rate times time. dr, distance that he rode, is also his speed that he rode times the time that it took him to ride. So these two added together give me 60, which means these two added together give me 60. Whoops. So rate that he walked, time that he walked, plus rate that he rode times time that he rode is going to equal 60. Alright, so let's start plugging some things in. I've got a 3 for that. I've got a 9 for that. And I still have a 60 here, but what about my time and for walking and riding? Well, I can take that and set that up for one of the variables. I can say that TW equals 8 minus TR, right? Subtract that from both sides and set it equal to TW, which means whenever I see a TW, I can put 8 minus TR in. So this one right there will change to that. So we'll put an 8 minus TR here. And then here, I've already got a TR. I don't need to change anything there. So now, instead of having a TW and a TR, two different variables, I only have one variable here. Oh, and there's a plus sign here. I forgot to put in there. This plus sign right there. All right, so I do the math. 24 minus 3 TR. Okay. Plus 9 TR, which is this one right here. Okay, I'm going to add my TRs. Negative 6 plus 9 is 6, or negative 3 plus 9 is 6. Okay, subtract my 24. And that gives me 36. Divide by 6, divide by 6. The time that he rode was 6 hours. Okay. So what are they asking for? They're not asking for how much time it took him to ride. They're asking how much time it took him to walk. Well, I know that if I added my time walking plus my time riding, I get 8. And if the time riding was 6, that means the time walking had to be 2. Okay, so that's example 29.1. And we'll do the next two videos, or the next video will cover the next two examples here in problem set or exercise 29.